Welcome back! Previously, we understood what TensorFlow is and how we implement simple code, end to end. Now we'll take a deep dive into linear algebra and implement simple code which will help of TensorFlow. Linear algebra is a fundamental topic in the subject of mathematics and is extremely pervasive in the physical sciences. It also forms as the backbone of many machine learning algorithms. Hence, it's crucial for the deep learning practitioners to understand the core ideas. Let's see what linear algebra is. It's a branch of mathematics, considering the linear equations, such as linear functions and the representations with the matrices and spaces. Linear algebra is central to almost all areas of mathematics. Linear algebra provides the first steps into vectorization, presenting a deeper way of thinking about parallelization of the certain operations. Algorithm written in the standard for-loop notation can be reformulated as matrix equation, providing the significant gains in the computational efficiency. The good understanding of linear algebra is essential for understanding and working with many machine learning algorithms, especially deep learning algorithms. Let's take a look at scalars. These are the built-in types. These are like int, float, complex, bytes, Unicode in Python. In NumPy library, there are 24 different and new fundamental data types to describe the different types of scalars. Let's see how we code and what the things are that we have to keep in mind while we code in Python. This is our spider, where we're writing the code in this box and we'll be getting the output here. This is already discussed in the earlier videos. Now let's see how we go about it. First, we're trying to understand what a scalar is and the importance while we do code in Python. We're declaring two variables, a and b, and the values a and b are 5 and 7.5 respectively. These are considered scalars. Now let's see that there's a function in Python which is known as type. This returns the type of the variable a. Let's run the program. As you can see, the type of program is considered to be class int. It's an 8-type scalar. If I run this, it gives class float because b is 7.5. So Python itself knows what is int and what is float just because of our type of value that we're giving. Let's say I convert this 5 to 5.0 and then run the program. Both my a and b is float. If I do not give this decimal, it becomes int. A is int, b is float. Let's do some mathematical operations on these scalars. Now I'm trying to add two variables, a and b, which is already declared. The output is already declared. That means this is a simple addition, so we could do the other different types of operations like subtract, multiply, etc. Let's see how we do it. I'll subtract 7.5 from 5. That means I would get a negative result. The output of 8 divided by b is 0.666. That is 5 divided by 7.5. Obviously, the answer should be less than 1. Here, we're multiplying 5 and 7.5. This is 37.5. We've already discussed scalars. Now let's move to vectors. The representation of vector is in this form, where capital X is equal to x1, x2, x3, and so on. To identify the necessary component of a vector, the IDE scalar element of vector is written as x, I, that is I, the index. The examples are x0 is equal to x1, x1 is equal to x2, so we need to be very careful that the first element is the 0 index. Let's see an example. I've defined x as the vector 1, 2, 3, and y as vector 4, 5, 6. I'm trying to print the type of x. The output of x is list. Let's see what I've added. It does not give the vector addition. It's just adding the elements. That is 1, 2, 3, 4, 5. Let's now import the NumPy. We've imported NumPy as NP. These are the allies, and we're declaring a variable z, which is np.r, and addition elements, and the parameters that we're passing is x and y. Let's see how it works. As you can see, the z is the vector addition of these two variables, x and y. That is 4 plus 1, 5, 2 plus 5, 7, and 6 plus 3, 9. This is called the vector addition. and we're using the NumPy package for the vector addition of two different vectors. As you can see, the type of z now comes out to be numpy.ndArray. This is a type of vector. We'll now see what a matrix is, and how different things are performed there. This is a simple diagram of a matrix where the matrix variable is considered to be A, and the different elements add A11, A12, and A13, and so on until A1n. That means advice if I see the number of columns is equal to n. And if I say the number of rows, it's equal to m. Therefore, the number of elements will be m cross n. It's denoted as A is equal to Aij in brackets m cross n. This is the dimension of my matrix. Now let's see a simple operation. One of the most important and simple operations is the multiplication of matrices. Let's see how it's performed. This is one metric, A, B, C, D. It's having 2 rows and 2 columns, hence it's called 2 by 2. Then comes E, F, G, H. Now when we're multiplying it, it's not a simple multiplication. It's a matrice multiplication. The output will be the first element of the matrice. Will be AE plus BG. The second will be AF plus BH. Then the second draw in the first column, CE plus DG. Last one, CF plus DH. This is the way of matrix multiplication. It appears to be very complex when I give you the formula, but when we do the coding, all the libraries will take care of these. Let's see how we do it in the code. We've imported NumPy as NP, hence I won't be doing it again. Let's define a matrix here. You already know the formula. This is one of the matrices that has been defined with the help of the NP package. So here we'll see how we're defining a matrix. If I simply type X, the output of X comes something like this. So we could say it does. And matrix notation 1, 2, 2, 3. I want to know what the type is for X. Let's have a new matrix. Now execute the line. Amazing! Here you can see all the different variables, and this is the matrix. I declared a variable, z, and we've declared the variable x and y, and storing it with z. Let's run the command. Nicely done. This is the x. You already have the formula. You could check whether it does right or wrong, and what type of multiplication my NumPy is doing. I could see the output here. If I type z, it comes out to be 18824. So a few more things which you could do with the NumPy is that, for example, if you simply write a new variable, say s, which is equal to x.mean, axis you want to give, what you don't want to give. The output comes out to be 2. My x was 1223. So now what it's doing is finding the mean. If I give the axis a 0, then run it, it gives us the output element-wise. What it does is 1 plus 2 divided by 2, then 2 plus 3 divided by 2. Therefore, it's given the mean this way. If you do not have any type of parameter here, what it does is it gives the mean of all the elements. There are many other things which you could do with the NumPy library and matrix, but the most important thing is that you should do some hands-on with the mathematics for the matrice. It becomes easy for you to understand the data set and what type of manipulation you want to do with the data. For example, here you know why the matrix is, but you want to know what was the shape of it. It gives 2 by 2, sometimes to get a data set which is having hundreds and hundreds of columns and hundreds of rows, and you cannot count it, or you can't see it. Its scroll bar will be too big. So what you do is just use the function .shape and then identically see how many rows and how many columns you have. So this is a very small idea about the matrix. How you declare a matrix, how you declare a variable, a scalar, what a vector is, vector addition, normal addition, and how we multiply in case of a matrix. There are many other things like matrix multiplication, matrix inverse, matrix transpose, and so on. As we proceed ahead in the upcoming sections, we'll learn each and everything and all the functions that'll be used. So this was all about the code.